11.2, we're going to learn how to find the area of different types of polygons. So far we've learned how to find the area of a triangle and the area of rectangles and parallelograms and trapezoids and all those four-sided shapes, and we're going to expand that now to finding the area of any regular polygon. Regular meaning all the sides are the same and all the angles are the same. And just like the last section, we're going to base this on triangles. So there's some vocabulary we have to get through first, and then I'll show you how we can use triangles to find the area of a polygon, and then we'll develop a general formula for that. So if you know what a central angle is, central angle, it's kind of like the central angle that we had on a circle, only we don't have a circle, we have a polygon. So a central angle would be an angle that goes from the center and then out to two vertices. Okay, so this would be my central angle. And if I put all my central angles in, I can figure out how much each one would be. Because now I've made 1, 2, 3, 4, 5 central angles, and together they make a full circle. So the central angle is 360 divided by the number of sides. Okay, this is a new word for us, apothem. The apothem is similar to an altitude. Okay, it's going to be an altitude of one of the triangles that's made when you form all your central angles. So an apothem goes from the center and is perpendicular. Is a perpendicular bisector of one of the sides. Okay, so a segment from the center to the midpoint of a side, and it is perpendicular. Okay, so we have right angles here. And then we got a radius of a polygon. A radius is from the center, so a segment from the center to a vertex. So that would be like one of these lines. Any one of these would be a radius. Okay, so it's not the same as an apothem, because apothem goes to the midpoint of a side, radius goes to the vertex. And if you look, if we do both of these things, if we put in our apothem and our radius, I get a right triangle. And then we can use all of our trigonometry to find different pieces that we're going to need. So let's look at how we develop the area of a regular polygon. I'm going to start by making my triangles again. Okay, so I've got these triangles. And the area of each of these triangles is 1/2 the base times the height. Well, the base, this would be the base. The base is the length of a side. The height is actually our apothem. If I take half, that'd be the area of this. Okay. Now, I've got 1, 2, 3, 4, 5, 6 of these triangles. I have 6 sides on my shape. So I would have 6 I have 1/2, okay, times 6 times the length of a side times my apothem. This 6 times length, okay, since this is length and I'm timesing it by 6, okay, that would be this. What do we call this? This is the length around the shape. We call that perimeter. So, the area of any regular polygon equals 1/2 the apothem times the perimeter. Okay, so now let's look at some examples and see how we can find our apothem and our perimeter in different cases. I've got 3 cases here. These are the only 3 cases that you're ever going to be presented with. They're either going to give you the length of your apothem, the length of a side, or the length of the radius. So let's take these one at a time and see what we have to do. So if I've got my apothem, I'm going to want to use this right triangle here to find, we'll call it x. Once I know x, if I double it, then I'll have the length of my side, which will give me my perimeter. So then I'll have my apothem and my perimeter, which are the 2 things I need to find area. So how are we going to find x? Well, I've got a right triangle. If I can figure out one of these angles, either this one or this one, I can use trigonometry to find x. We know how to find these angles, the interior angles of a regular polygon. We also know how to find central angles, which would be this. Okay, central angle is the whole thing. Central angle is usually easier to find. So I'm going to take 360 divided by 5, and that will tell me how big my central angle is. So in this case, it's going to be 72 degrees. I don't have a full central angle, I have half of it. So I'm going to cut this in half and get 36 degrees. So this is 36 degrees. This is 5. I'm looking for x. So if I use SOHCAHTOA, I can figure out what x is. I'm looking at this angle. I'm looking for the opposite side, and I know the adjacent side. So opposite, adjacent, that's tangent. So I'm going to take the tangent of 36 degrees, and that should equal x over 5. I've got my calculator here. We can figure out what is the tangent of 36. Make sure we're in degrees. Tangent of 36 is that. If I multiply both sides by 5, that'll leave x alone. So I'm just going to multiply this by 5. And that's how long x is. So x is 3.63. That means each side is double that. And I've got 5 sides. So that's my perimeter. So P equals 36.33. I'm going to take 1/2 my apothem, which is 5, times my perimeter, 36.33, and this will be the area of my shape. So times this by 5 and times it by 1/2. I get 90.82. Let's see how to do this when we have a side length. If this is 8, I can get my perimeter pretty easily. P is 8 times 5, 40. Now I need to find my apothem. Well, if the side is 8, this piece is 4, so I'm going to use that same right triangle. Okay, so I've got 36, I know this is 4, I need to find x. So again, I'm going to do tangent of 36 should equal opposite over adjacent. So tangent of 36 again was that number. So 0.73 equals 4 over x. if I cross multiply here, I'm going to be taking 4 divided by that tangent to get x. So I get 5.51. So if I want the area, I'll take half my apothem times my perimeter. There's my area, 110.11. Okay, now these aren't going to be the same because they're not the same size pentagons. All right, let's see what happens when we have our radius. Now I need to find both things. I need to find my apothem, and I need to find x over here. We use SOHCAHTOA again. Okay, 360 divided by 5 will give me my central angle. Cut it in half again. I'll get 36 degrees. I know that this is 10. If I'm looking for A, I'm going to need to do cosine. So cosine 36 equals A over 10. So if I take 10 times the cosine of 36, I get 8.09. That's what A is. If I'm looking for x, I'm doing opposite and hypotenuse, so that's sine of 36 equals x over 10. So if I take 10 times the sine of 36, I get 5.88. And that's half of a side. So if I double that, and then multiply it by how many sides I have, I've got my perimeter, 58.78. Then I can do 1/2 apothem times perimeter. There's my area, 237.76. Okay, and if they have units, if this was inches, okay, this would be inches squared because it's area. Okay, so those 3 examples encapsulate every type of problem that you have. Now, you're going to have different triangles, okay? I use the same shape, so I always had 36 degrees, but if you have a 9-sided regular polygon, you'd take 360 divided by 9, which would be 40, so your central angle would be 40. You're going to take half of that and use that as the top angle in your triangle. Okay, and then you do your SOHCAHTOA.